Hey, I've been doing a bit of sort of software archaeology, and essentially found myself recreating a classic video game, Thrust. It wasn't something I kind of set off to do. It just kind of happened. It just kind of happened. I'm just demoing the game at the moment, so if you played this back on the BBC, I'm pretty sure you remember it. It's quite iconic, and there was also a C64. And the idea is you have to lift this pod off each planet. You can destroy the generator and do it. You get bonus points. And basically, as the game progresses, it gets over the caverns you descend through get ever more complicated. This is the second level. More turrets, a bit more things to avoid. I put a little. You can actually obviously couldn't do this in the original game, but in my little reinterpretation, there's 6 fundamental levels, and if you press the key 1 to 6, you can switch to that level. So this is like level 6, which starts to get a lot more complicated. And there's doors and switches and things. The sort of unique look of it with the individual sort of scanline rendering. I've crashed. With the individual scanline rendering, it's hard to play this and talk about it at the same time. With different spawn points, so further you descend, you'll get spawned at the nearest spawn point, basically. The next spawn point. I think I've got a site bugging that logic because it should spawn around here. So the individual scan lines were to make the scrolling work smooth enough on, like a BBC Micro back in '86 when this came out, and it was written by a chap called Jeremy Smith. I think he was somewhere between 16 and 18 when he wrote it, and he went on to work with Peter Irvin on Exile, a very famous BBC game with future AI and way ahead of its time. The other thing you can do, what the game did at the end of the level, let's just go down to the bottom of this one. There's a door here. Door. So down here, it's quite complicated to get this one down here. Now we've got to navigate all the way back at this cave structure. With the power textures below. Else we have to get anyway, so as you can see, I'm not very good at it. It's a long time since I played it properly, but it would have 6 main levels, and it would cycle round to like reverse gravity. Let's put onto a more interesting level. So reverse gravity is the next one, and then what was particularly hard was then it cycles to invisible landscape, and only when you put the shield on or the field pickup tractor beam thing can you see the landscape. You can see the objects, but not the landscape. So you have to sort of carefully descend this thing. And then the final one, which was just, I think I completed all of these back in the day, and then the final level is, press it again, is reverse gravity and individual landscapes, which is very, very difficult. It's very difficult. You wouldn't think reversing gravity could make things so tough, but it does. It really does. So that's the game. I've also added a few if we go back to a fairly straightforward level, especially sort of square bracket keys. I've added some filters so you can kind of play it a bit more like it might have looked on your colour TV. I didn't really get much time to play the BBC on a colour TV, so when I first got a BBC, I was playing it on a tiny black and white screen, which is probably like a 12-inch black and white TV or something. So there's a filter that looks a bit like that. Then I put a green screen on. And an amber. I had a very small green screen monitor at some point. Again, just absolutely tiny. And still loads of curvature on it. So I just put those in just to, they're fun to do, and they give it that sort of authentic kind of feel. Interesting. I think at some point it looks like I've broken the static. The static should be animated with static, so I need to go fix that. Anyway, that's the game. I recreated it. So it's written by a chap called Jeremy Smith. I'll to him. And if I just stop that, it will eventually stop in a second. Created by a chap called Jeremy Smith. He sadly passed away in the early 90s, I think. Really sad. Obviously sad when anybody passes away so young, but goodness knows what game was great, very clever cookie. So that's the game. The original game, you can see I was spending a lot of time with these things side by side. This is the original game on the right, running in the BBC emulator, and my version on the left. The viewport on mine is slightly bigger because in the original it only fills part. I've got the same resolution, but it fills part of the screen on the original. And again, I think that was for the scroll to make it scroll quickly enough on the BBC. So a combination like the scan lines, every other line being rendered, and then a small viewport let the scrolling work. So I was eyeballing these things side by side and made this game. So it's pretty faithful. If you play it, it feels the same, sounds the same, exactly the same, graphics are the same. So the interesting question is, how did I get it so accurate? And the answer is I found some disassembled source. And you have to excuse me for a moment. I'm just going to go to my blog because I've got the link to it. A chap has created this commented disassembly. Hopefully this thing will stop making sounds in a minute. I can mute it, can't I? It should stop in a second. If not, I'll mute it. There we go, muted. Okay. So this chap has done a disassembly of thrust, which is great, very helpful. He's commented it. And that resulted, that source code, and me studying that source code resulted in this TypeScript application, which I'm not going to go through the code in great depth, but I thought I'd just give a sense of how I worked on it, because I used Claude to help me understand the original source code, which I thought was quite interesting. As a tool to drill into the 6502, and I'm sure the comments helped it. And I'm going to do an experiment with uncommented 6502. The Exile disassembly is available, but it's barely commented, so it'd be interesting to see what Claude can figure out from that. And I had originally planned to do like a live version of making a change to this, and I did record that, but like a complete muppet, I'd turned all the microphones off. I'm just going to talk through the process of what I did, and it gives you a sense of how I worked. And as I say, I didn't set off meaning to do this. How I actually started was just for some reason I was like, I wonder. I was kind of looking probably at the latest capabilities of the coding agents, and the proclamations from Anthropic and OpenAI, the crazy levels of hype around how much we can do. I was like, okay, I wonder if you can create a basic game for me. I was like, right, I wonder if you can create thrust for me. So I used the latest Claude Code with Opus 4.6 running in extended thinking mode. I gave it a big spec for thrust. It had access to original source code. And I said to it, go and recreate thrust for me. I'll see if I can dig out some screenshots and pop them somewhere. It created something that ran, which is quite impressive. It very vaguely resembled thrust, and it had the scanline stuff, but somehow really rough. It didn't understand gravity, so the ship didn't fall right. It controlled weirdly. It was basically slop. In fact, slop is being too kind to it. It was horrible. But that's sort of thinking, I wonder how the specific mechanics of thrust work. Like how does it work? How did this work on an 8-bit micro? What are the systems? How did it work? And that's what I found with disassembly. And what I started to do was feed it into Claude, as in the website Claude, the website version of Claude, which is what I was doing here, and asking questions about the various systems in turn. So, like one of the first questions I asked it was, how's the level data put together? And it gave me some information on that, and I took that and I don't actually save that one because it was before I realised this was quite interesting and might be interesting to others. But it gave me a spec for that, and I fed it into Claude and with some instructions, some guidance, and it built me a decode levels tool. And it wasn't perfect first time around because I hadn't explored all the systems. So it didn't have all the context it really needed. I hadn't gone for everything, it was missing bits. But it gave me a basic, it let me draw the basic landscape. So that was like step one. I was like, oh, I wonder if we can extract, how do we get the ship on the screen? So I managed to extract my first go at it was just to draw it. So I used like a vector approach, but then as it rotates, it looked very rough. I was like, oh, interesting. So what's the original do? And it turned out the original had hard-coded sprites for each rotation, which somebody had optimized, I guess Jeremy Smith, had optimized to look right at each rotation. So I was able to use Claude to extract the sprites, and again I got it to build me a tool which was this decode sprites JavaScript, and it just there's the object sprites from the disassembly, and it basically builds a little I think it builds. I looked at this at quite a high level and quite a while ago now. At least in the amount of ground I covered in last week. I guess it was only last weekend, but I had a very busy week. It basically decodes it to like a BBC frame buffer. Yeah, there you go, new BBC frame buffer, and then converts that into a PNG, and I get a load of sprites out that look like the first sprites. Great. I had to do a bit of work to pad them right so that it rotated correctly. But yeah, so I was able to extract all the sprites. So I got the ship on the screen, and so on and so forth. The physics was interesting. So, two things that were really interesting to work on were the physics and the sound. So the physics uses a very... it takes a couple of shortcuts in the physics, and it doesn't run at the full frame rate. It runs. I've written in the README what it runs at because it is quite interesting. If you want to work the timing, there's quite a bit of data to how the physics runs because it was running on an 8-bit and it ran all the time. You probably wouldn't have enough CPU left to render and stuff. So the timing was really interesting. In fact, the first cut of it worked, but was really fast. It was far too agile. The ship didn't have enough weight, but the constants were the same in both games, in the disassembly and this game. So it had to be timing, and I spent quite a bit of time with Claude and looking at the disassembly, figuring out the timing. And once the timing was right, it felt perfect, which is great. And it does if you play the BBC one and you play the recreation. The controls are the same. You can move between them, which is kind of what became interesting to me. Was because creating a game like Thrust with just running at the frame rate of a device using normal deltas for the physics and the rendering, well, you could knock that out really quickly, but it would feel nothing like Thrust, and it doesn't. We tried to do that, it doesn't. But what became interesting to me was how does the original game work, and how would I translate that so it had all the feel that it was Thrust. It wasn't kind of Thrust, it was Thrust, but just recreated in a modern language and running in the browser. And yeah, you could run the emulation in the browser. This is all completely artificial and just for fun. But yeah, so that was the physics. And then the other thing that was really interesting was the sound. So getting the sound, my first step at getting the sound effects to work, they're okay. The bullets sounded about right, the ship engine sounded wrong, the explosion sounded wrong, but it just didn't have the same tones as the original. And I spent some time playing around with them and I just couldn't get them the same. And because I spent so much time on the physics being the same, I really wanted the sound to also be the same. So in the end, I ended up emulating the original sound chip. It was in the BBC, the SN76489 sound chip, which apparently was also in the Sega Mega Drive, rather Sega Master System, which I learned as I was working through this, which was interesting. And also the BBC MOS interface to it. The MOS was a machine operating system on the BBC, and people would interface to the sound chip through various operating system locations in memory, Osword calls for sound, poking a word into certain parts of memory. So I was able to find, again, I'll just go back to my blog for a second. I was able to find that somebody had disassembled the MOS code, and you can download the MOS code. And again, I was able to interrogate that with Claude, and between that and the BBC Advanced User Guide, and the specs of a chip, I was able to generate a spec for the sound, which is sound system full, which basically explains comprehensively how the sound works. And from that I was able to generate an emulated sound system, which is what we're looking at here, and the sound identical, which is really what I wanted. And it would have been very difficult to get that by any other means, I think, because it's so timing specific. It's so specific. It would be hard to just recreate. When I did Elite, I actually sampled the sounds, but the sounds in Elite are mostly discrete. So it kind of worked sampling the sounds, but in Thrust, like the thrust is you hold down a key and it thrusts, and the explosion just didn't sound right. So I wanted to go through this approach. Also, Elite, I wasn't trying to do like this perfect recreation, more of a homage. I wanted a feel, but it didn't have to be identical. I mean, I was using solids, solid polygons and things, so it didn't feel as important there. But once I started on this little adventure, the accuracy felt really important. So what I was going to do originally was kind of work through a problem with Claude as I had with when I was working on the game. And as I left the game yesterday, I hadn't put the demo mode in. So the original game goes through the title screen, and then it plays. I'm looking at my version now, but then it plays this demo here, where it blows up the turret, picks up the fuel, and picks up that, and then flies off with the pod. And I hadn't done that, so oh, interesting, let's find out how that works. So this is the rough approach I did. I took the disassembly and put it into Claude, and basically said to me, okay, let me know how this works. And it goes through that and essentially reveals that it injects timings and key presses into the game loop. So on a certain time, press a key, release it so many milliseconds later. And with a certain random, slight bit of randomization in it, and that's what it came out. So then I did what I often do, is okay, I understand how this works now, but I want to add this to Claude Code. Can you create me a spec for Claude Code? And it would create me a spec. I did that, and I put it into the TypeScript code, and we ended up with this input TS, which basically just abstracted the input away a little bit, so we could get it from the demo loop. And we also got demo.ts, which is essentially controlling the demo and feeding the key sequences in at the right point in time. Great, but it didn't work. It did work, but when I watched it, it was far too fast. And again, it comes back to understanding the timings. The first pass at understanding it was this happens per tick, but there's different tick cycles. There's the VSync 50 Hertz tick on the BBC. The BBC was PAL, which ran at 50 Hertz rather than NTSC's 60 Hertz. But then also the tick loop is kind of locked down a bit further, and I had to go through this to figure out the tick loop. And great, I got the timing right. We made some slight modifications to the code, nothing significant. Literally just putting on the right timing, and it worked. But it missed the turret when it fired at the turret. And it missed the turret because it turned out that this hadn't mattered until now, but it turned out that the player's starting position was ever so slightly off. Ever so slightly. And that meant it missed the gun turret. And when I was uncovering that, I was like, hang on a minute, well, how did the original do this? Because I'd put the level decoder together right at the start. So I found out that actually there's multiple spawn points, and I'd forgot about the multiple spawn points, but I was like, oh yeah, there's these different spawn points in the game. So I went through the spawn points. That took quite a lot of poking backwards and forwards to get right, and I still think actually I've adjusted it X but not Y. It needs to be slightly higher, the starting position. But that it doesn't really matter. It doesn't impact the gameplay at all. Things still appear in basically the right place. It doesn't cause any problems. So I'll probably leave that. Oh, excuse me. But yeah, I backed and forth with it, and the spec that came out of it, by the way, was demo mode.md, describes a demo. Yeah, and you can see there's a whole bunch of these here, which are basically the sort of the subsystems I was exploring in the original game and trying to extract. It's a teleport animation. The teleport animation is this. If we just let it, if I just start the game, it's that when it ping in, and the original version of that looked nothing like. The spec that it extracted was nothing like the original. And actually, the way I got that working in the end was I just recorded the original game as a video and captured the frames of animation. I pasted the frames of animation into Claude Code and said, right, recreate that, and it did recreate it almost perfectly. So I thought that was really impressive from the coding assistant. It wasn't hard. It's something I could have done in half an hour, but actually, it did in 5 minutes, which is great, particularly when you're doing it every weekend, and it's not particularly interesting code. And I'm not sure. The interesting thing about this process wasn't writing the code. The code is not complicated. It's a 1986 game that ran in 32K of RAM. It's not particularly complicated. That's not a sort of a slight on the original developer. It's amazing that the original developer got this working on 8-bit, and Exile is something else. I'm in awe. But by high-level languages, all the power we've got, it's a simple game. It's easy to put together. So it wasn't the coding that was interesting. It was the understanding of original systems, and it turned out that kind of recreating them and making sure the feel was right, the timing was right, forced me to drill into those things and really understand the game. So I've put the source code online. That gives you some insight into how I kind of put this thing together. I really enjoyed it. It was real fun. I played this game a lot when I was young. I've got a BBC. Obviously you can't see. I've not got my camera on. I've got a BBC Master on the desk just to the side of me, and I occasionally pop up Thrust on there, along with some of the other classics, including in the emulator on my Mac. And it's one of those games I do return to, and it's just nice to have gained this understanding of how it really works. And going through these code bases from the 8-bit era gives you real respect for the developers. I mean, amazing. Amazing that you can squeeze these things into such limited capabilities. Fantastic. Yeah, so that's really interesting. I hope that's interesting. Sorry I couldn't walk through the process. I'd recorded something in a week that didn't need sound. And in fact, I didn't want sound. I turned all the sound off and forgot to turn it back on. Thanks for watching. I hope that's interesting, and I'll see you for whatever I do next. Cheers.